So we have now a typical problem that involves the use of the error bound on alternating series. What we want to do is we're given a series, in this case -1 to the n plus 1 over square root of n plus 3, and we want to find the smallest n so that the partial sum Sn approximates S within some boundary. In this case, we want it to be no further away than 0.01 or 1/100th from the true sum. So we observe here what we know, which is that S minus Sn is less than an plus 1. So what we want to do is we want to choose n so that this is going to be less than 0.01. In other words, we know that based on the work that we saw in the previous videos, we know that this number is going to be less than an plus 1. So what I want to do is choose an plus 1 so that an plus 1 is no larger than 0.01, because as long as it's 0.01 or less, this statement is going to give us a number that's less than 0.01. So what we want to do is let's first of all define an. So an is equal to 1 over the square root of n plus 3. In other words, that's just the positive part of this definition, where then we use the -1, the n plus 1 to make it alternate. We can easily see that the given series is the sum from n equals 1, sorry, -1 to the n plus 1 of an when we define an in that way. So what we want is we want an plus 1 to be less than or equal to 0.01. That means that I want 1 over the square root of n plus 1 plus 3 to be less than or equal to 0.01. Let's bring this around here. I'm going to take the reciprocal of both sides of this, and we know that when we take the reciprocal of an inequality, we have to switch the direction of the inequality. So this gives us the square root of n plus 1 plus 3 is just n plus 4, and that's going to be greater than or equal to 1 over 0.01 is 100. I'm going to square both sides of this in order to solve for n, so that gives me n plus 4 is greater than or equal to 10,000. And then finally I'll solve the inequality by subtracting 4, so that gives me n is greater than or equal to 9996. So there's the answer. It's 9996. And notice, by the way, that I've put in here the problem is find the smallest n so that Sn approximates S within 0.01. If I didn't put that in theory, you could cheat and say, well, it looks like it's about 10,000, so let me just put in, 100 trillion or something like that. Certainly, if you used 100 trillion terms, you would get an approximation that is much better than being within 0.01. But the goal here is to find the smallest n that meets this condition. So that's the answer, and this is how you solve this type of problem.